So you can start.
Oh, wait.
Nice.
Yeah, it's better.
Don't move this too much. Yeah.
You're not preparing 0, 0.
Move it after Okay, I'm Manushi.
And I'm Vidushi.
And today we're going to do a presentation on topic 8.1 of the chapter energy production. So first off, we start with defining what is specific energy and energy density. Specific energy can be defined as energy per unit mass. The formula is very simple, and you can compare it to specific heat capacity because it mainly focuses on energy produced per mass of a substance. That's why the formula is energy produced over mass of the substance. And then energy density can be defined as energy per unit volume. And the formula is E over V, which is energy over volume. This is just an example of a chart of different types of fuels of renewable, non-renewable primary and secondary resources and their specifications. Now we classify energy into primary and secondary, energy resources into primary and secondary. Primary resources are the resources that have not been transformed or converted by consumers. They are, you can say that they're naturally occurring, most of them, and therefore the examples are wood, coal, and oil. For secondary resources, these are the type of resources that result from the transformation of a primary resource, and these are usually man-made, and these are what we use as electricity from like nuclear powers or heat or anything.
So there are two types of sources of energy. The first one is renewable source of energy. A renewable source of energy is energy produced from sources which are naturally replenishing but are limited to some extent, but we use them at a rate which is lesser than how fast they're produced. Some examples are hydropower, geothermal, wind, solar, and different types of biomass such as wood and wood waste, solid waste, landfill gas and biogas, and etc. The second type is non-renewable. A non-renewable source is a source of economic value that cannot be readily replaced by natural means on a level equal to its consumption. Some examples include nuclear fuel and fossil fuels such as crude oil, coal, and natural gas. Energy can be produced through many different ways. The first one is fossil fuel power stations. It is a thermal power station which burns the fossil fuels such as coal, natural gas, petroleum to produce electricity. They release very large and significant amount of power. The machinery required is, the machinery converts the energy into mechanical, which then operates the electrical generator. The advantages are that it's easy to find as they're located all throughout the world, and whenever they're found, they're usually found in large amounts together. It is extremely efficient, as I mentioned before. They generate huge amounts of electricity from just a small amount of resource. They can easily be transported as the pipes can be laid underground to not obstruct anything else, and it will be cheaper in the long run even though it can be expensive in the starting. This also generates a lot of jobs as people will be used to build the transport systems and take care of the reservoirs. And it's easy to set up as all it requires is just a lot amount of power. Disadvantages are the environmental degradation. As you know that fossil fuels, whenever they burn, they produce a lot of carbon dioxide. And carbon dioxide is the major leading cause of global warming. It needs a lot of reserves as running a power station requires a lot of energy, and to be able to sustain that much energy every time, the reservoir needs to be extremely close to the plant, or else it has to be transported from miles and miles of distance, which can then lead to harm to the society as well. There are public health issues as burning fossil fuels causes a lot of air pollution, which thus then leads to deaths of millions of children throughout the year, and it can also trigger asthma. The last one is that it's a finite energy source as it is limited in number, and we're using it much more than it can be replenished.
The next source of energy production is nuclear power stations. Nuclear power is generated by nuclear reactions such as fission, decay, or fusion, although fission is the most commonly used reaction for this process, that generate heat, which most frequently is then used in steam turbines to produce electricity in a nuclear power plant. It can produce up to 100 electron volts of energy by just splitting one nucleus. The most commonly used element for such reaction is uranium-235 or plutonium. And it is classified as non-renewable energy and it's considered as a disadvantage for such reactions because it is not possible to maintain the amount of elements for such reactions. When a neutron hits the nucleus of either of the elements, nuclear fission takes place, which causes the nucleus to split in two. The fission reaction releases energy and neutrons. These neutrons are free to move and are thus able to hit multiple nuclei, which results in a chain reaction. The reaction is also moderated by control rods that absorb excess neutrons, and this is crucial as it causes a small delay in further fission reactions, which allows time to change the position of the control rods for release of neutrons. A fission nuclear power plant is generally composed of a nuclear reactor in which the nuclear reactions generating heat takes place, a cooling system which removes the heat from inside the reactor, a steam turbine which transforms the heat and mechanical energy, an electric generator which transforms the mechanical energy into electrical energy. The disadvantages of this process are that it produces radioactive waste, which can be either low-level waste, which are disposed away from in places away from human contact, but they have to be away from human contact for at least 100 to 500 years for the radioactivity to die down, as well as high-level waste, which causes a disposal of fuel rods, which still contain traces of radioactive plutonium or uranium, and these might actually take up to 2,400,000 years to die down.
Wind generators are also another form of producing energy. Energy is generated here when the wind turns the blades, which then spins the generator to create the energy. There are two principal designs of a generator, a horizontal axis and a vertical axis. In both cases, a rotor is mounted on an axle that is either horizontal or vertical. Hence the names. The rotor is rotated by the wind, and through a gearbox, this turns an electrical generator. The electrical energy is fed either to a storage system or to the electrical grid. It is possible to estimate the maximum power available from the horizontal axis wind turbine of blades area A. In 1 second, the volume of air moving through the turbine is VA, and the speed of the wind is V. So this is the formula which we can use to calculate to estimate the maximum power output. But when we are using this equation, there are a few assumptions made. The first assumption is that all kinetic energy can be used, as there are presence of other turbines which will disturb the flow of air, leading to reduction in the energy from turbines. Advantages of wind generator is that no energy costs are there, as all you mostly need is just wind which is turning the turbines. No chemical pollution. Capital costs can be high but reduced with the economies of scale. Easy to maintain on land but not so offshore. The disadvantages is that variable output on daily or seasonal basis, as not all the time like a seasonal thing, and their site availability can be limited in some countries, and not all countries have enough land to support for huge wind farms. And there's an well,
The next source is hydroelectric power, and this we have actually learned for years now. And what we've learned is that there's a dam, water falls on a turbine, it turns, and it produces electricity from the mechanical energy. So basically, hydropower is power derived from falling or fast-running water, and the mechanical energy that is produced from the turbine is then converted to electrical. The advantages of this are that it's a renewable energy source with comparatively low cost, and except for building up a whole dam or a reservoir. After that, the long-term effects of it are pretty low cost. And with a dam or reservoir, it is also a flexible source of energy which can be varied based on public demand. And it also produces very low rates of greenhouse gases, which are actually eco-friendly now. So it makes it eco-friendly, I'm sorry. The main storage system for these kind of power productions is pump storage systems. This method stores energy in the form of gravitational potential energy of water, pumped from a low elevation reservoir to a high elevation. This method uses electricity to start the pumping process, which then starts the turbine to produce energy that can be supplied to other areas. Although it uses energy, which is one of the disadvantages, but the surplus of energy later that is produced regulates it.
the last part which we will be discussing is solar energy. There are different ways to which solar energy can be utilized. The first way is through solar heating panels. In a solar heating panel, it contains a pipe in a black plate which contains glycol water mixture, which is then circulated by a pump. This has a black plate, as we know that black is a great absorber of heat, which will then be able to absorb most amount of heat and cause the glycol water mixture to become heated. The second way is through solar photovoltaic panel. The first photocell, which was generated by Alexander Edmund Becquerel in the middle of the 19th century with a semiconductor technology, it was possible to produce photovoltaic cells. A photovoltaic cell contains of a single crystal of semiconductor that has been doped so that one type is a p-type semiconductor and the opposite face is an n-type. These n-type and p-type indicate the most significant charge carriers in the substance. Normally, there is an equilibrium between the charge carriers in both halves of the cell. However, when energy in the form of photons falls on the photovoltaic cell from the N region to the P region and hence around the external circuit, the electrons transfer the energy to the external circuit in the usual way and do the most useful work. But the efficiency of this is rather low, just about 20%. The advantages of a photovoltaic panel is the maintenance is very low, there are no fuel costs, and individual houses can use them. Disadvantages is that it has high initial costs and it requires a lot of money to set this up first. And it is not that efficient.
Any questions? You can raise any question regarding whatever they have spoken on. Anything. I have a question.
Yeah.
Why the efficiency is less?
Of it. It's yours.
Okay.
You spoke like it is 20%, right?
Yeah.
20% is quite less. Still, many countries are coming up with this idea. I think
There is a max time limit. It's
just
only
4+ minutes.
How many minutes was it?
Around 15 minutes.
Wow.
What?